This is a pulley problem, and we're trying to find the length of this entire blue pulley that goes around the entire system here. We're going to look at three different parts, and that's going to be the curved section over here on the left, the curved section on the right, as well as the straight segment on the top and the straight segment on the bottom. And because of all the symmetry in this shape, the curve on the straight segment on the top is equal to the straight segment on the bottom. Those two tangent segment lengths are going to be equal. So when we're looking at finding this entire length, 40 is going to be the sum of the two pinks. We need to find the yellow and find the turquoise, then we'll have the entire length. What we're going to do is draw in this segment, and a radius is tangent to a perpendicular. We're going to draw in this segment. Again, the radius is tangent to a perpendicular. And since these two radii are both perpendicular to the same segment, that means that those two segments have to be parallel to each other. We know that's got to be true. We're going to draw in a bit more. We'll connect the centers of the circles together, and then also draw in the segment that goes from the center of the smaller circle and is perpendicular to the radius of the bigger circle. And what that does is create this green rectangle. What we know is that this was a right angle, this was a right angle. We constructed this segment to be perpendicular, so 3 right angles. This one has to be 90 degrees because there's 360 degrees in the quadrilateral. In a rectangle, we know the opposite sides are equal to each other. So since the diameter for this circle on the right is 10, that means that this length is 5. So then this length is 5. The radius for the bigger one was 9, which means that this length is going to be 4. Again, we know the opposite sides are equal to each other, so this entire length is going to have to be 20. And now we're going to focus on the little triangle we have right here. What I know about that triangle is that this is a right angle, so it is a right triangle. We are going to have to find an angle measurement for this one because this yellow curve here on this left, this yellow arc length is going to be, drawing this segment down here, this central angle, which I'll call theta, theta over 360 times 2 times pi times your radius of 9. I need to figure out that angle theta. To do that, I'm going to figure out this little angle in the green right triangle. I'll just make up a variable and call that x right now. From this angle, 20 is the opposite, 4 is the adjacent, so we could say that the tangent of x is equal to 20 over 4. And if we solve that, x is the tangent inverse of 20 over 4, which would simplify to 5. That's that little angle. Again, because of all the symmetry, we would have the same exact triangle below it. This would also be x degrees right here. So if I double that, that would give us this whole angle right here. And if I take 360 minus that, then that'll give us the angle theta that we want. So theta is going to be 360 minus 2 times the tangent inverse of 5. 2 tangent inverse of 5 is 2 of those x's. 360 minus that gives us theta, and that's about 202.6 degrees. I'm going to store that in my calculator as a letter. Let's go ahead and store it as x in my calculator, and now I know that I'm going to put x in when I actually put this into the calculator, so x or theta. Now over to the right, I'm going to draw in this other radius. And what's happening here is that since this radius is parallel to this radius, the segment connecting the centers acts as a transversal, and I'll make it a little darker now. What I know is that corresponding angles are equal to each other. So this x that we have is the same thing as right there, which is also going to give us x for this bottom part because it's corresponding to that x. In other words, this entire angle is 2x. So if I call this angle alpha, alpha would be equal to 2 times the tangent inverse of 5, and that's approximately 157.4 degrees. I could store that in my calculator as A. And to get this turquoise arc length over here on the right, it's going to be the stored value of A over 360 times 2 times pi times the radius of 5. So this is the yellow length, this is the pink length, this is the turquoise length, and if we sum all those up together, we'll get the entire length to be about 85.56.